All right, number one. How many grams of KNO3? So the first thing we need to do is find potassium nitrate on this curve. Here it is. So we're talking about this curve here. Now, it says, could you dissolve in 100 grams of water? Notice the standard way of presenting this information is grams of solute per 100 grams of water. So we don't have to worry about this right now. At 10 degrees Celsius, so what I do is I go over to 10 degrees Celsius, I go up till I hit the curve, and it looks to me like we're talking right here. That's where I hit this curve. I'm going to go with 22 grams. And then at 50 degrees, it turns out I can dissolve a heck of a lot more. It looks like I can maybe do 85 grams. You know, I'm just going to write the 85. It's going to be naughty and not write the grams. Number two, how many grams of NH3? Here's NH3, so we're talking about this one here. It's a gas, and as it goes down as temperature goes up. How many grams of ammonia could I dissolve in? Again, it's 100 grams of water at 10 degrees Celsius. So I go over to 10 degrees Celsius, and I see at 10 degrees Celsius, it looks like I could dissolve 70. But at 50 degrees, I could only dissolve, it looks like, about 30. All right, number three. As the temperature of water increases, what happens to the solubility of solid compounds? Well, here's our solid compounds. You'll notice, for solids, in most cases, the solubility increases. So I'll put increase. What about the solubility of gaseous compounds? Well, gaseous compounds, you know, this is a bad question because you don't know this, but it turns out that HCl is a gas. It turns out ammonia is a gas, and it turns out that SO2 is a gas. You know, I guess you could look at your notes. Okay, so if you look at your notes, you would notice that, so I don't feel so bad. It decreases. All right, I've got to move this out of the way for a second. It says, if 100 grams of water is able to dissolve 20 grams of KClO3, what is the temperature of the water? So in this case, I need to find KClO3. KClO3 is right here. Here's the curve for it. All right, I'm able to dissolve 20 grams of it, so this axis is grams. The temperature of the water must be 45 degrees Celsius. So if you don't mind, I'm just going to write 45. I'm not going to write the degrees Celsius. For number 5, for each of the following, write either saturated, undersaturated, supersaturated, or saturated. I'm going to move this over a little bit to give myself a little bit of breathing room here. Okay. So, 60 grams ammonium chloride, 80 degrees. Ammonium chloride is here. So I'm talking about this curve. 60 grams, okay, at 80 degrees is right here. Notice I'm below the curve, which means it's capable of dissolving more, which means it is undersaturated. Now the next one is 60 grams HCl at 80 degrees. So we're going to find HCl. Here's HCl. We're going to dissolve 60 grams at 80 degrees, so we're right here, but notice now we're above the line, which means that we are supersaturated. I'm just going to write super. Now I have 110 grams of KNO3. KNO3 is this one here. I've got 110 grams, which is here, and the temperature is 60 degrees. Here's 60 degrees. And here's 110 right here. So this is 60 and 110. You'll notice I am right on the line for KNO3. So in this case it is saturated. So I'm just going to put sat. And then I have 110 grams at 40 degrees for sodium nitrate. So let's find sodium nitrate. Where are thou? Here's sodium nitrate. So we want to go to 110 grams. We want to go over to 40 degrees. And we'll see we're above the line. And if you're above the line, you are supersaturated. So if you're under the line, you are undersaturated. If you're on the line, you're saturated. And if you're above the line, you're supersaturated. Let's take a look at this next question. Okay, so for number 6, here's what we've got. We're going to put a 50-gram crystal of KClO3. So let's see what that is. I'm sorry, KCl. Here's KCl. I'm going to put a 50-gram crystal into 100 grams of water at 10 degrees Celsius. And I want to know how many grams of crystal is going to be left. So in other words, I'm going to subtract from 50 however many dissolve at this temperature. So at 10 degrees for KCl, it looks like I could dissolve 30 grams, right? So 30 grams of it would dissolve. So if I take 30 grams of this 50 grams of crystals and put it into solution, that leaves me with 20 grams are left behind. Let's try our next one here. Alright. The next question says, how hot would the sample have to be to dissolve all of it? So in other words, at what temperature would I dissolve 50 grams of KCl? So here's 50. I would have to get it to, it looks like about 75 degrees. At 75 degrees, that's what would happen. Okay, now, which two of the followings are supersaturated solutions? That means when I graph them, they're going to be above the line. So let's try 30 grams of ammonia at 60. So here's 30 grams, here's 60 degrees. And you know what? 30 grams, 60 degrees is above the line for ammonia. So that's one of them. Let's try the next one. I bet you it's not the next one. Why would he do that? Alright, so I'm going to go to 50 grams. I'm looking at ammonium chloride in this case. Here's ammonium chloride. So I'm going to go to 50 grams. I'm going to go over to 50 degrees. And it turns out I am right smack on line. So that's saturated. That's not supersaturated. Let's try the next one, KNO3. Here's KNO3. That's that steep one. I'm going to go to 60 grams. I'm going to go to 40 degrees, which is here. And you notice that is below the line, so that's undersaturated. I bet you this is my answer, but let's just double check. So we're doing KClO3, potassium chloride, which is right here, and chlorate, sorry. And let's see. 30 grams at 60, so here's 30 grams, here's 60 degrees, and I'm just barely above the line. So yes, that one is also supersaturated. Number 9 is a tricky question. Okay, let's see what we got here. My water sample is 20 degrees. Again, notice it's always 100 grams of water with these problems I'm giving you. There's 40 grams of KClO3 in it. So let's just see if we're saturated or supersaturated, okay? So at 20 degrees and 40 grams for KClO3, I'm considerably supersaturated. In fact, it should only be able to hold 10 grams, and I've got 40 grams. So that tells me I'm 30 grams supersaturated. There's 30 grams of a solute that wants to come out of solution. So when I add this tiny crystal, it is going to form a 30-gram crystal, because what's going to happen is all those ions that are supersaturated want to go back to being saturated, wants to go back to equilibrium. They just need a crystal to form on. So basically the way you solve these problems is you simply see how many grams above the line are you. When you add a crystal in, that many grams of solute will come out of solution and go onto a crystal surface. Let's try another one of these. Let's see now. I'm going to have to go to another page. Hang on. Alright, now for number 10, sorry, a lot of times people think this is about number 10. It's not. This question is a standalone question. It doesn't even have anything to do with this. Alright, so if I have 125 grams of sugar dissolved in 25 grams of water, which one is the solvent? Remember, solvent means whichever one you have more of, so therefore sugar is the solvent and water would be the solute. So that's just a question of understanding what the word solvent means. Solvent means the one that there is more of, the majority component. Alright, let's look at these next ones. Number 11, which of the substances listed above would be most likely to dissolve in water? Here's my hint. H2O is a bent molecule, and so this question really has to do with like dissolves like. So what we need to say, what we're really saying is water has polar bonds and it's a bent molecule, so water is a polar molecule. So any one of these that will be polar are going to be soluble in water. So what that means we need to do is we need to take a look at each of these and see if it is a molecule with a dipole, if it's a polar molecule or not. So what we have to do is we first look to see if the electronegativity difference leads to polar bonds. It does here. So we go, well, I have polar bonds, and trigonal pyramidal is such that it can be a polar molecule. So this one, I'm just going to put a little P next to it. That doesn't look like a P, does it? That's a polar molecule. Now, NCl3, if I look, NCl3, these bonds are not polar, so I'm going to put a little N, meaning it's non-polar. SO3 has polar bonds, but this shape, trigonoplanar, does not put those charges on opposite sides of the molecule. So it turns out trigonoplanar molecules that only have two different atoms in them, binary compounds, are non-polar. So I'm going to put an N next to that one. SO2 has polar bonds and it's bent, so this one is polar. And CCl4 is both tetrahedral, which can't be polar, and these bonds are, oh actually those are non-polar bonds as well, so I'm going to put an N here. So, which of the substances would be likely to dissolve in water? Water, these are polar bonds and it's bent, so it's a polar molecule, so that means SO2 and NF3 are the ones that I would get. So I'd say NF3 is a polar molecule with a dipole, and so is SO2. Would I expect SO2 to be soluble? Let me move this up a little bit. Would you expect SO2 to be soluble in SO3? SO2 is polar, SO3 is nonpolar, so no, I would not expect them to be. Would I expect SO2 to be soluble in NF3? Polar, polar. So yes, like dissolves like. Yes, I would expect them to dissolve each other. Would you expect CCl4, which is nonpolar, to be soluble in NCl3, which is also nonpolar? So yes, I would expect that. Let's continue upwards. Oh, my last question. Why won't oil dissolve in water? The answer is H2O is polar and oil is not. Hey, I certainly enjoyed this homework. I love this stuff. I hope you do too. See you later.